Welcome dear students. So in our first video lecture we have discussed about general method of preparation for amines. Now just as we did in unit 10, 11 and 12, in this chapter also now we will continue with some chemical properties related to amines. So first chemical property that we are going to study is about basicity of amines. Basicity of amines. So amines are basically derived from ammonia. We know that ammonia acts as a base. What kind of base? It's a Lewis base. Okay? Because of the presence of this lone pair, since this lone pair is present on nitrogen atom in ammonia, ammonia behaves as a base. It's a Lewis base. Okay, due to presence of the lone pair. And from our acid base theory, we know that if availability of this lone pair or this electron increases, the basicity will also increase. Okay, and when we were discussing about nucleophilic substitution, then also I discussed about nucleophilicity and basicity. Okay, so while discussing that, I told you about how lone pairs work, because we have seen substitution versus elimination, and then we have seen that presence of lone pair or a negative charge, okay, makes something a stronger base or stronger nucleophile. Okay, base can remove hydrogen. So this is what ammonia can do. Ammonia has a lone pair and it can donate this pair to any molecule and act as base. Now, since we are discussing amines, suppose I replace one hydrogen with a methyl group. Okay, that means alkyl group. So this is primary amine, this is 1 degree amine. Now we want to know that introduction of this alkyl group or methyl group in amine will increase or decrease the basicity. Okay, whether it will increase the basicity or whether it will decrease the basicity, we want to know. Now the simple explanation is that, see, we know that methyl or alkyl groups are plus I effect producing group. Okay, R is a plus I effect producing group. That means it can push electrons. So just imagine that if an alkyl group pushes electron towards nitrogen, what will be the result? Since R is pushing electron towards nitrogen, the electron density around this nitrogen atom will increase. Okay, the electron density around the nitrogen atom will increase, and as a result of which, what will happen? This lone pair or the availability of this lone pair will also increase, because the density of electron is increasing around the nitrogen due to plus I effect. Okay, so from this fact we can easily conclude that if we have a 2-degree amine, then obviously there will be more inductive effect. Now if we have a 3-degree amine, suppose, this is 3-degree or tertiary amine. So basically inductive effect will be more here. There are 3 electron pushing groups. So it's very clear that with introduction of more and more alkyl group, that means as the degree of the amine increases, the electron pushing alkyl groups increases the density, electron density around nitrogen more and more. Okay, the density keeps on increasing, and if the density is increasing, it implies that the basicity will also increase. So we can easily conclude that 2-degree amines are more basic than 1-degree amine, and 3-degree amines are further more basic than 1-degree amine. Okay, it's quite intuitive, but the thing is, this sequence or this order is order of basicity of amines in gaseous phase. That means this order is only applicable when we are discussing or when we are analyzing the basicity of amines in gaseous phase. Okay, so the question arises that what if we change it from gaseous state to aqueous solution? What will happen if we take an aqueous solution of amines? Okay, and yeah, let me write one more thing. Primary amines are more basic than ammonia. Okay, you have to keep in mind, because there is no alkyl group to push electron to the nitrogen. Okay, so primary amines are more basic than ammonia. So let's see what will happen if we take an aqueous solution. So in aqueous solution things will change. We have seen, just keep in mind what we have seen. We have seen that plus I effect increases basicity. Okay, now we will see extent of hydration. Extent of hydration means we will see that what type of amine will dissolve better in an aqueous solution. Okay, and we will see that we can easily check that a primary amine, it's ammonia, I guess it's primary amine, yes. Let me use red pen. So it's H, it should be NH2, one hydrogen, okay. So there will be a hydrogen bonding with OH2. OH2 is water. OH2 is water. This dotted line represents hydrogen bond. So we can see that primary amines can form 3 hydrogen bond, secondary can form 2, and tertiary can form 3 hydrogen bonds. Okay, and with the extent of hydration, the basicity should go up. That means it tells us that 1 degree amines should be more basic than 2 degree amines, and 2 degree amines should be more basic than 3 degree amines. But see, what is the problem? Problem is, just see the point number 1. Inductive effect says that 3 degree should be more basic than 2 degree and 2 degree should be more basic than 1 degree. It's just the reverse. And then we have another factor. It's called steric hindrance. Okay, it's steric factor. Let me just put it. Yeah, it's called steric factor. Steric hindrance. What is steric hindrance? Suppose if nitrogen is surrounded by 3 alkyl groups, then what will happen? These alkyl groups will cover, this lone pair, and they will have, a lot of repulsion will be there between the bonded pairs and the lone pair. Okay, there will be a lot more repulsion because alkyl groups are bulkier groups and they have electrons. Okay, because these are bonded pairs and lone pair has also electron, so there will be repulsion. Okay, so that is another factor which suggests that 1 degree should be more basic than 3 degree. So now we have these 3 factors, and when we combine all these 3 factors, then what we see, we will get 2 type of things. So basic order in aqueous solution. So first we have to remember that if we have methyl, then this will be the order. That means if the substituent is methyl, then order is secondary, tertiary, primary. Combining all those factors, hydration, we have combined the factor like hydration, then steric hindrance and inductive effect, and combining all those factors, what we have got, that for methyl substituents, this will, except methyl, if you take any other alkyl group like ethyl, then order will be like this. Okay? No, my first order was correct actually. My first order was correct. Methyl is a smaller group, so we have less steric hindrance. And in ethyl, steric hindrance is stronger. That means I have to separate it by 1 degree, 2 degree. 2 degree, 1 degree, 3 degree, and then ammonia. And then in the next case, except any group except methyl, it will be 2 degree, then 3 degree, then 1 degree. So this is the basic order. Now, from our syllabus, what we have learnt till now in organic chemistry, you got 3 things. 1, acidity of phenol. Then you got acidity of carboxylic acid. And now you have got basicity of amines. Okay, so acidity of phenol, acidity of carboxylic acid, and basicity of amines. You have to keep in mind, just go through these 3 topics very, very carefully. There is a very, strong probability that out of these 3 topics, you'll at least get 1 question from any one topic. At least there will be a question from one topic. Either it can come from acidity of phenol, or acidity of carboxylic acid, or basicity of amines. Okay, so you'll get at least 1 question from these 3 topics. So go through them carefully. Now we have discussed basicity of amines, 3 degree, 2 degree, 1 degree, but see, we have discussed mainly the basicity of aliphatic amines. The amines that we have discussed are aliphatic in nature. Okay. So now what we will do, we will discuss basicity of aromatic amides. We will discuss basicity of aromatic amides. So this is aniline. Now we will see what a conjugated system or what resonance can do. Okay. So see, we have a lone pair on nitrogen atom. So there is a pi sigma pi sigma pi sigma pi sigma, that means conjugated system. So resonance is possible. It will move, this electron can move to the adjacent bond. If it moves here, then valency of this carbon will be exceeded. So to maintain that, we have to move it here. And see, you will get a positive charge on the nitrogen, because you know nitrogen is losing one electron. How? See, as soon as this electron jumps here, the bond will be like this. Both the electrons have came from nitrogen actually. So nitrogen loses one electron. Now in the next step, what will happen? This negative charge will jump over here, and to balance it will go here. Okay. In the next step, okay. So we got this resonance structure, and what does resonance structures imply? So it tells us that the lone pair is not static on nitrogen atom, but it has been delocalized throughout the ring due to resonance. So the availability of lone pair around an atom, that means nitrogen atom, will decrease as a result of which aromatic amines are not basic. Actually, it's not true to say that aromatic amines are not basic. The main fact is that aniline is not basic because of the resonance. Okay, so I wrote this answer, I wrote this purposefully. Last time in your first class test, I have given you a question that explain why phenol is acidic in nature, and most of you have just written 2 or 3 lines or few lines. Okay, so this is not how you explain a reason. Keep in mind that if inductive effect is the reason, then you have to show the inductive effect, how it is happening. If resonance is happening, then you must write or must draw resonating structures. Okay, if you do not draw resonating structures, it won't work. You have to draw those structures and then you have to explain what you have drawn. Okay, so keep in mind that you have to explain with the this technical part. You have to draw all the resonance structure and then you have to explain about that resonating structure, that due to resonance the lone pair has delocalized. Okay, so this is all about the basicity of amines. Okay, in the next video lecture we will discuss about other chemical properties related to amines. Okay, thank you.